Hey everybody, Jeff here for CA161B. We covered arrays last week as well as in the previous week with strings. So we're going to cover a couple advanced topics today as we get into Module 4. This is kind of arrays part 2 is the content for this week. I have two different videos here. I'm going to demonstrate doing some stuff around, editing elements in an array around adding and removing elements, which we often talk about shifting. So I'm going to demonstrate that in this video. And then I'm going to do some two-dimensional array stuff in a separate video. Little bit different approach here. Just we're going to basically work on one program the whole time for each of these examples. Okay, so if we look in 1113, which is shifting values in an array. We're not going to go through this interactively here, but let me just kind of demonstrate what we need to do here. If this table here, this first table is an array of currently 10, the capacity of the array is 10, right? So I can hold 10 of these items at most. And the current count is 8. That's how many array elements have been filled at this time. You can see the numbers here, element 0 through element 7. Okay, if we want to remove the element at index 3, which is highlighted in bold here, we can't just say it's gone, right? We can't just change that 17 to 0 or basically say remove that. What we have to do is we have to take, you can see there's a typo right here, 0, 1, 2, 3, 4. That should say 5, 6, 7. We have to take element 4 and move that into this position, then element 5 and move that into this position, element 6, move that into that position, and element 7 and move that into that position. And you can see that's what happened here. Okay, we often talk about shifting values in an array as a way to fill up an empty space. And so if I take away an element in an array, I have to move everything past that 1 to the left. And I have to do it in order, one at a time. I can't start from this one. If I write the 12 into here, I overwrite the 10. So I have to write the 18 into here, then the 9 into here, the 10 into here, and the 12 into here. Okay, so that's how we would remove something. If we wanted to insert something, it'd be the same thing. So let's take this array down, this array here, and let's say that I wanted to insert, the value 99 in index 5. So basically between, 4 and 5, I wanted to put a 99 here. I'd have to move the 12 over and then the 10 over and then place the 99 in here. And so in the case of removing, I have to reduce my value of count by 1. In the case of adding, I have to increase my value of count by 1. And so I'm going to demonstrate the removal piece. And here it goes through, and the section goes through this in quite a good amount of detail here. We're going to write a program to demonstrate deletion of elements, but the discussion for this week is around inserting. So I'm not going to show you how to do that. But you could take my code if you want, or you could do it more exactly how it's stated in the assignment. Either way is good. Okay, so what we first are going to do here is we're going to declare, or we're going to define our array constraints, if you will. And so we're going to set our array to be a maximum size of 10,000 elements. And just to show you a few different things, I'm going to state that our maximum value for each of the array elements is going to be 99. So we're gonna create random values between 0 and 99. Okay, we are going to declare our array. We are going to do our random seed thing. And what we're going to do is we're gonna say I want to fill my array somewhere between, this will tell us how many initial elements. Random value between 20 and 39, right? If you look at what I did here, I'm going to create a random value, and I'm going to take the mod of that so that my remainder will be between 0 and 19. You divide something by 20, so your remainder will be between 0 and 19, and add that to 20. And so this will tell us how many elements we're going to fill the array with. You could change this to whatever you want, right? You can have it be 500, or you can do, you can do the full 10,000 if you want. But I'm just going to do it this way for now. And now we will fill up the array with random values. And we need to use this, right? Okay, if we take the mod of 99, then we'll have values between 0 and 98. If we take the mod of 99 plus 1, which is what I'm doing here, then we'll have values between 0 and 99. All right, let's check and see if this works. We're just going to print our array elements here real quick and see if it works. Okay, you can see I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 elements. This time I got a lot more than 20. And you can see I got a number as high as 97 in the first example. I did get a 0 in the second, or 2 zeros in the second, and I got a 99, right? So you can see I'm kind of demonstrating my full range here, as I go through. I would like to print this out a little bit nicer. Okay, and I think that one of the ways that you get to practice with arrays a lot is creating functions to display the data, right? And so, maybe more work than needed in this class, but it's good practice to create functions that display the data in more complex ways. Okay, so we're going to create and remember, we pass an array in by reference, so we don't have to state the size here, but we do want to pass in the size because we need to know how many to print. Now I'm going to make this a little bit more general purpose, right? And so if I want to format my array, like let's say I want to format my array here so that my numbers, like if I'm printing something like this, you can see my numbers are not very well aligned, right? So what I want to do is I want to print my numbers to kind of look more like that in a table. Okay, so we're going to justify the numbers, but we have to give them the right number of digits. Okay, so given a max value, the number of digits we will need will be log base 10 of that value plus 1. Okay, so in other words, if my max value is 99, the log base 2 of 99 is 1.8 9 something, I think, because we know that the log base 2 of 100 is 2, right? 10 to the 2 is equal to 100. Okay. If this math is like, eyes glazed over math, you may have learned this, you may not have learned this. Don't worry about it. This is not, not trying to teach these log functions here, but it's just a way to avoid hard coding, right? You could hard code here the field width, right? And you could say, okay, for my max capacity, my index's field width would be 4, 0 to 9,999, and my value field width would be 2 for 0 to 99. But we can do some trickiness here, and it's maybe less trickiness, and it's more of just making your program require less manual changes when you make changes. Okay, so I'll do this here by setting, why is it not, oh, because I haven't done a index width. So I'm going to create two width field, or two width variables. I guess the other reason here is I'm using my size here. So if it turns out that my size is only 8, then I only need 1. Then I'm going to set my index value to 1, right? Versus hard coding it up here. Okay, so this is the type of stuff I wouldn't really expect to see in this class. If you print out your stuff in a nice way and you have some of these issues with the digits, it's not generally going to be a problem unless I'm very specific in the assignments. But I like showing some of these other ways that you can practice with the coding here. In order to use log base 10, you need to have math.h in your code here. Okay, the other thing we're going to declare here is how many values I want to print per row. Now, one thing you've probably noticed about my videos is I have my font relatively large. If I was just developing on myself, these fonts would be smaller. But you can see here that I can print out maybe about 20 numbers in the row here. If I want my code to be a little wider and I want to do that, then I have fewer numbers, obviously, right? So I'm just going to say 6 per row. We're going to see what that looks like right now. Okay, and then I'm gonna start to prepare to print my array. So we need to print everything up to the size. And what I'm going to do is I'm going to print the index number in the parentheses. And I'm going to do that right justified using the index width. Right, index width end parenthesis. And then I'll put a colon after and a space. And now I'm going to print the value, and I'm going to set that right justified width to value width. And that is array in of I, okay, because that's my input passed in array of I. And then we'll put a few spaces after that. All right, so I've started j is equal to 0 here. I've incremented j, and if j is equal to num per row, then I need to print a new line. And I got to set j equal to 0 again. Okay, so this is my counter to tell me how many different ones I want to print. And then at the end of my function, I want to print an end line just in case, because I may not have ended on an end line. This means sometimes you'll get an extra end line if you have an exact multiple of 6 in your print. So that would be a further enhancement to make here. Okay, so let's try that and see if this works. Typo there. If I was running this in VS Code, it would tell me as I'm typing in when I have my typos. Okay, so there's my output. Why is it not working? It's because I'm not calling the array, display array. Okay, so I want to call A and enum. Okay, so there's my nicely printed array. The other thing that I'll do, just because I think it makes this look a little bit better, I am going to indent my array by a couple spaces. So I need an initial 2 spaces here, which is right here at line 28. And then each time I do an end line, when I hit J is 6, or J is my num per row, then I add another couple spaces here. It looks like, for the purposes of how my screen is set up right now, nope, I can't quite get a 7th in there, right? If I do that, I get my 7. Right? So it's really, based on your, the size of your screen and what you want to do. But this is kind of nice. You can run this over and over and you kind of get a sense of how the random values are being filled in each time. Okay. Now, if I wanted to finish this program here, I would create an insert element function. And I'll leave that at that. Like I said, if you want to use my code for the discussion, I think the discussion says to have the user enter the numbers, well, you can just do this instead, right? And you can demonstrate inserting using this code. Feel free. Totally okay. But now let's talk about deleting. And actually, I think I'm going to change this to 0, and I'm going to write a comment here. Insert element just thinking out loud. I didn't think of this ahead of time, but this might be what your function looks like. Let's talk about delete element. To delete an element, we need to know what position to delete. So we're going to do int delete element. We're going to pass the array. We're going to pass the size, and we're going to pass the position. And then we're going to return the return value is the new size. To know what position to insert and the value to insert, return value is the new size. Okay. We're going to talk about our boundary conditions here in a moment as well, but let's keep going here. So what we're going to do here, like if we go back to here again, if I want to delete index 3, then I have to start at 3, and I have to get the value at the next index and copy it over. And if you look at these arrows, I start at 3, then I do 4, then I do 5, then I do 6, and then I do 7, but I don't have to do 8. Right? So let's, so why did I do that? Okay, let's try that. So we're going to say for int I equals position, I is less than size minus 1, because we have to stop one position early. Then we're going to say A of I is equal to A of I plus 1. So we're just going to copy the value in the position 1 to the right. And then we return our new size. Okay, so we'll shift left all elements starting at position plus 1. Okay, the main thing here is if you don't understand why this is size minus 1 and size, then you want to hand trace this through, and that will help you. Okay, so now let's try it. And let's just do this inside a loop here. Del position equals mine. We'll do this with some error checking. Okay, so if our input value is within the range of the array, otherwise we'll valid position. Try again. And I'm using the value -1 to indicate an invalid value, right? So while my del position's a -1, I'm going to ask over and over until I get a value. Okay, now that I have a good value, then I can set my new size. Remember, this delete element will return the new size of the array. And we will display the array again after we do the delete. Okay, so let's give this a shot. Okay, so let's go ahead and delete value or element 10 right here. Okay, so if you look and see what happened, the 6 moved from 11 to 10, the 83 moved from 12 to 11, the 35 moved from 13 to 12, the 4 moved from 14 to 13, and so on. And you could see the 79 at position 24 is now 23, and my array is one less in size. Okay, let's talk about boundary conditions for a moment here. When I test, like if you submitted this code to me, the things that I'm going to test, right? I'm going to test a couple random things like this. Let's see what happens there and make sure that works. Oh, let's try 22 and see if that works. But I'm also going to check the first element. And you can see what happened is it didn't like that. Okay, and so I realize here, I messed up here. That's going to be greater than or equal, right? Because we're starting at 0 here. Okay, so now we'll fix that. So now 0 works, right? The other thing I'll often check will be the last one. Okay, now the last one did work here. Okay, and the question is what happened, right? And so in other words, if I get to delete element and I'm giving it size of 37 or position of 37, but that size is 38, this this for loop actually doesn't execute. And we simply return size -1 here in this case. So in other words, trying to delete the last element from an array, all you do is change your size and you're good, right? The memory space still here has a 32 in it, but we don't really care. It's not valid anymore. Okay. The other thing that you have to be, the other testing that I will do here is, and I think in my notes here, yep, I have a list of all these special cases, right? So talking about boundary cases, special cases. Deleting the first element of an array. Deleting the last element of an array. Deleting the only element of a one element array. That's something you would need to check. Trying to delete from an empty array, which I haven't demonstrated here. Think about what your insertion rules might be, right? Inserting at the front of the array, inserting at the end of the array, inserting into an empty array, and trying to insert into a full array. So these are the different things you got to remember and keep in mind. I likely will test all of these. And the way I test your programs in much more detail is I usually write a program to do the testing. And in this case, I would have to modify the code to do an empty array, right? And so I could do that, right? I could set the size, I could set enum equals to 0 and see what happens. And I can run a bunch of commands here to insert and delete and see what happens. Okay, so this code here you can use. There's one more thing I think I want to do this. Yeah, so I'm going to make a note. Note that if size position is the last element, the for loop does not execute, and we simply reduce the size by 1. Sometimes I'll see code that has that check, right? And it will say something, and I have this note here, I'll show you, right? You could have that there, right? You could just say a position is equal to size, return size -1. And the reason that, you might want to do that is depending on how you implement this down here. But in this case, this for loop won't run, so there's no reason to have that there. But it is a boundary case, right? So we need to test. Don't forget to test. Boundary cases. Okay. I'm looking at my notes here to see if I'm forgetting anything I want to cover. I think this is it for this example. So, like I said, for this discussion, you could start from scratch if you want, or if you've already started. Feel free to use this code. You can fork the replet, or I think you should be able to access the replet, or just copy the code in, and you can implement this insert here. I think for good measure, I'm going to put a comment here, is like, think about adding a menu to allow users to insert and delete. Insert element, delete element, or quit. You know how to do that, right? And you could just build this in a menu. Could get fancy and add a clear the array command as well, which is actually, think about what that might be. Super easy, actually, right? So that you can test the boundary cases. So look forward to seeing some of that stuff in the discussions. This is the kind of stuff that as you build these more complicated programs, you're going to do over and over and over. Like I've written this type of display thing a million times, and every time I write it, it's different because it needs to be a different thing. Sometimes it's a table in boxes, sometimes it's a single element per row, and so on. But it's a great way to get practice. And so that is section 1113, which talks about shifting. And that's pretty much it for that. I'm going to end this video, and I'm going to record in whichever order you watch it in. It doesn't matter. So I would say instead of that, saying I'll end this video and check out the video on the two-dimensional array as well, where we're going to develop a cool find the hidden spies game. And so, as always, let me know feedback and how it works for you. Talk soon.